Welcome to this tutorial on building REST API with Next.js 13 and Supabase. In this video, we will start from scratch, build our REST API and protect our routes. And also, we will dive into advanced topics like course headers and rate limiting. If you are ready, let's get started. First, let's create our Supabase account and Supabase project. I have already an account like this, maker dev, and our password. Okay, cool. Now we can create new project like this, Supabase REST API, and we need to generate a password for our database. Cool. Now we can choose our region. This is the closest one to me. Okay, cool. Now we can create our project like this. While it's creating our new project, we can create the next project as well. To create next project, we can use npx create next app latest, and it's going to be experimental app because we will use the new app directory. Cool. The name of project is Supabase Next.js 13 REST API like this. We will use TypeScript, ESLint, Tailwind CSS, source directory, and this import alias. Okay, cool. Okay, we are done. Now we can go to our folder, Supabase Next.js 13 REST API, and we can open up our VS Code like this. Okay, cool. Now we have our project in our VS Code, and also we can get this page and we can split this screen. Okay, cool. But first we need to run our dev server like this, yarn dev. Let's refresh our page to see if it works. It's compiling at the moment. Yeah, it works. Okay, cool. Now we need to set up our Supabase project. We need to link our projects together. For that purpose, I will create another terminal. And in it, our Supabase project inside of this Next.js project. Okay, cool. Now we need to log in our Supabase account. To log in, you need to write Supabase login. If you didn't install the Supabase CLI first, you need to install it to use these commands. Okay. Now we need to get our tokens. We can open this page and create a new token for REST API tutorial like this. And we can copy this token, paste into our terminal. Okay, now we are logged in. The next thing we need to do is linking our projects. To make this happen, you need to write Supabase link -- project ref like this, and we need to get our project ref from our dashboard, project settings, and the reference ID like this. And it will ask our database password, but if you don't know your database password, you can always reset with this button, and we will generate a new one and copy this and reset password. Okay, cool. Now we can paste this. Cool. Now we have created the connection between our cloud Supabase instance and the local project. The next thing that we need to do is creating our TypeScript types based on our database schema. To make this happen, we will create a script in our package.json file. And in this file, we will create our script like this, gen types, and it will be Supabase gen types TypeScript, and it dash link. We can use this flag because we have created our connection between our projects, and also we need to put these types into types and supabase.ts like this. For that purpose, we need to create our types folder. Okay, cool. Now we can say that yarn gen types. And let's check if it created. Yeah. Now we can access our database schema with this script. Okay, cool. The next thing I want to do is building the authentication flow, because we will protect our roots, right? That's why we need to create an authentication system in our application. Let's create this. To build our authentication logic, we can check the documentation of Supabase. In the auth section, there is auth helpers and the Next.js app directory. We can follow this. First, we need to install this Supabase auth helpers Next.js. And then we need to set our environment variables like this. We can copy this and we need to create a file called .env.local like this. And we can paste these strings into our file. And to get the strings, we can go to our dashboard, and in our dashboard, we can get those strings in the API section. First, we need to get our project URL like this, and also we need to get our public key. Okay, cool. Now we are done. The next thing we need to do is installing our Supabase JavaScript client library. You can install this library with this command, like this. And we can go back our authentication guide. First, you need to configure your middleware. Let's copy this code and create a middleware file in our root, like this, middleware.ts, and we can paste this code into our file. And also we need to set our matcher in this middleware, because we don't want to run this middleware in some kind of unnecessary files like static files or images or icons and etc. But remember that you can add the API in this middleware to exclude, because we will run this middleware in our root handlers as well. Cool. Now we need to import our types that we have created in the beginning. We can import like this, types Supabase. Yeah, cool. The next thing we need to do is creating our Supabase provider. We can copy this code and create a file in our app directory, Supabase provider.tsx like this. And we can paste this code. We need to also fix this import, not like that. Supabase. Yeah, cool. Now we need to wrap our application with this provider. To create this, we can go to our root layout and we can import our Supabase provider like this, and we can, oops, I put into wrong place. We need to put here like this, Supabase provider, and we can get this children into our provider like this. Okay, cool. Now we need to create our clients. For the browser, we have already created our Supabase instance in our provider. This is important because we need to use only a single instance of Supabase, because we will run our authentication logic with this single instance. That's why we need to use this instance in our application, in the client side, in the browser side, okay? And now we need to create another clients, another instances for our server and for our root handlers. First, start with our server component. To create our Supabase client, we can go to our lib folder, and in this folder we can create a new file called Supabase clients.ts like this. And in this file, first we need to import this, and also we will import the create root handler Supabase client like this. Now we can export const create server Supabase like this, and in this function we will return create server component Supabase client like this. And also we need to export const create root handler Supabase like this, and we will return not this, we will return this one. Okay, cool. We will use this client in root handlers, okay, and we will use this client in server components. Cool. Now we are ready. Now we can build our authentication logic in our components. I've created a simple login page for our application, and also I removed everything in our home page. Okay, and in our application we will let users log in with GitHub, but first we need to set up this. To make this happen, we need to go to our GitHub account, and in this dashboard we can go to our settings, and in our settings we can go to our developer settings. In this ORO section we can create new app like this, Supabase REST tutorial like this, and the HTTP local host 3000 for a while, and we need to get our callback URL from Supabase, right? For that purpose, we can go to our dashboard, and in this authentication section, we can go to our providers and the Github. In this section, we need to first enable this provider, and second, we need to copy this redirect URL like this, and we can register our application. First, we need to copy this client ID and paste into our Supabase dashboard. And now we need to get our client secret from Github. First, let's generate a new secret, but I need to verify this from my phone. Give me a second, please. Github. Yep, I approved. Okay, cool. Now we can copy this secret and paste into our dashboard like this. Okay, now we are ready, but there is another thing that we need to set up for our authentication flow. First, we can go to our SQL editor, and there's a section called Quick Start. In this section, you can use this user management starter. This is a SQL script that creates profiles table, and also every time user sign up our application, it will create a row in this profile table with the user information. But we don't need this website and also username and updated ad like this, and we can get rid of this one as well. Yeah, cool. Now we can run this function. And let's check if it's created the profiles table. Yeah, it's created. Okay, cool. Now we can go to our application. In this login form, we simply import our Supabase from the use Supabase hook that we created in our provider. As you may remember, we are using a single instance of Supabase, and we expose this instance with this custom hook. So we can import this Supabase in our client components. And we can go to our login form. And in this login handler function, we simply call supabase.o.signin with OAO. And provider is Github. Okay, cool. Now let's try to log in and authorize this app. And as you can see, we are logged in. Now let's get the user information in our homepage. I built this simple homepage where users can log out and log in again. And also we will list our to-dos in this section, but since we have no to-dos at the moment, we cannot list, right? That's why we need to create our to-dos table first. We can simply go to our Supabase dashboard and create new table like this, to-dos. And for the moment, I will not enable this row level security, but we will enable it later. And we will add column called task, and this is going to be text. And also we will add status column like this. As a default value, we will put waiting, and this is not going to be nullable since it has this default value, right? Cool. Now we can save our table. Okay, cool. I think now we are ready to create our first route for creating to do. to create our first route, we can close these folders for a while, and we can go to our API folder. And in this API folder, we can create a new folder called todo, like this. And in this folder, we will create a file called root.ts, like this example. And we can copy this example into our file like this. And in this root, we want to create a new to-do. And that's why we need to make this a post request, right? Post request, like this. And let's first get our task from this request, like this. Await request.json. And if there is no task, or task, the type of task not equal string, we will return next response, but first we need to import it, next response.json, like this. And our message will be wrong payload. And also we can put a hint for our users, right? Hint. Maybe you forgot to pass the task, like this. And also this is gonna be status 400, like this. If there is no task or it's not string, we will return this error. And now we can get our Supabase client. To get our Supabase client, const Supabase equals create root under Supabase, and we can import it. This is the function that we have created in our Supabase clients folder, right? Since it's a root handler, we will use this root handler function. Okay, cool. Now we have our Supabase client. Now we can insert our new to-do, like this. Const data error await Supabase from to-dos and insert task, like that. And if there is an error, we will return this error with the status code 500. And if there is no error, we will return our message like this. To-do is created. Okay, cool. Now let's try to call this root in our add to-do pop-up. In our pop-up, we have this function called add to-do handler. When the user writes something and click add to-do, we will run this handler. And in this function, we can call our API root to create our first to-do, like this. Try catch and const response equals await fetch, and we will call our API to do, and we will write our method as post, and also we will pass our task that we get from this input as body, right? And also we need to set our content type like this. And if response is not okay, we can console.log response. And also if response is okay, we can get our data like this, await response.json, and we can console log our data like this, right? And we need to set our input as empty string. Okay, cool. Now let's create our first to-do, hello world. And let's check if we created this to-do. Yeah, we have created our first to-do. So our root is working. Now let's try to add some row level security into our to-do table. To add this security layer, we can go to our authentication section and policies. As you can see right now, we have no row level security in our to-dos table, but first we need to enable it. Okay. And we need to create a new policy for insert. And we need to check if user is authenticated. And you can simply write true, but you need to target this authenticated role. If you don't set this, this is true for all roles, including the unauthenticated, which means public roles. So you need to set this authenticated role, and you can save this policy, right? Cool. Now, if user wants to create to-do, they need to be logged in, right? Let's try to call this API route with our Thunder client like this. Localhost API to do, and it's gonna be post request, and for the body we will set our task hello world from Thunder client like this. Yeah, like this. And let's try to send our request. As you can see, we will see this message, new row violates row level security policy, because with this Thunder client, we are not logged in. We don't send our authentication headers. But when we try to create our to-do with our application, let's check if we have created our to-do. Yes, we have created our to-do. To make this your root more secure, you can check if user is logged in like this. Check user is logged in like that. Const data and session await Supabase on get session like this. And if there is no session, we can simply return this response. You must be logged in to create a to-do. And let's try our Thunder client again. And it will say, you must be logged in to create to-do. So our root handler is now secured. No user can create to-do without login, right? Okay, now we can go to another methods like get, patch, or delete. Now we can create our get method in our to-do root. But first we need to set our row level security policy, because we only want to let users get to-dos if they are the creator of to-do, right? Because nobody can access another user's data, right? For that purpose, first we need to create a column in our to-do table called creator. This is a relational column. Let me show you. This maybe we can create from scratch. Yeah, insert column creator, and this is gonna be relational column, right? And it's relation with profiles. And you can set your action if the reference row is removed. You can set cascade. If we delete the user, it will delete all to-dos related to this user with this option. We can save this option. Okay, cool. Now we can create our row level security policy. And new policy, we can start with this one. For select, only authenticated users can reach to-dos, and also the o.uid needs to be equal to creator column that we have created before. Okay, now only creators can access their to-dos, right? Let's create our get method. Export async function get and request like this. And first, let's create our Supabase client like this with the helper function, and check if user is logged in. Data session and await Supabase old get session like this. Okay, if no session, we will return this response. You must be logged in to get to-dos. And if there's a session, we can get to-dos, right? Const data to-dos error await Supabase from to-dos select everything. And if there is an error, we can return this error. And if there is no error, we can return this response with our to-dos, right? Now we need to get these to-dos by calling this get method. To call this method, we can go to our to-do list and write our logic inside of this component, fetch to-dos, const fetch to-dos, and we need to wrap into use callback function since we are going to use this function in a use effect, and we can create try catch block if there is a error, we can simply console.log this error, and also const response await fetch API to do like this, and we will await for our response.json. If there is a to do, we will set this to do, and when the component is mounted, we can call this function fetch to do's like this. Let's refresh our page. As you can see, first we need to log in again. I think the refresh token is disabled. Okay, cool. But we don't have any to do because in our table we don't have this creator data for our to-dos that we have created before. Now we can create new to-do by setting our creator ID. To make this happen, we can go to our root, and in our root we can set our creator session.user.id like this, because we can get our user ID from this session object. And also we can put select here, and we can simply return our data when we created this to do. Okay, let's create this to do. Hello world from creator user, and let's refresh our page. As you can see, now we can access our to-do since we have defined our creator ID based on our user ID, right? Okay, cool. Now let's create another route for delete and patch request. I just created this button to delete our to-dos, and in this delete to-do handler we need to make a request to our delete route, right? But this is gonna be different than the other routes. This is gonna be dynamic route because we need to pass our ID into this route, right? Because we need to understand which to do we are going to be deleting. To create dynamic route, you can go to your to-do route and create a new folder called ID like this. And in this folder, you can create another root.ts file. And you can simply export async function delete, and in this function we can get our request, and also we can get our params like this. Params, and ID is gonna be string like this. This ID is the same thing with this ID. When we make a request to this route, we can get our ID from our param like this. Okay, const ID equals params.id. First we need to get our ID, right? And we can get our Supabase client like this, but we need to import this. And also we need to check if user is logged in, as always, right? if there is no session, we will return our error message, and also we need to import this. If there is a session, now we can delete our to-do. Const error await dot Supabase from to-dos, delete and match with this ID. If error, we can send our response, and also if there is no error, we can send our next response with this message. Okay, cool. Now we need to set our row level security policy for this delete method. We can go to our policy section and we can set a new policy, and we can use this template. If user is authenticated, and also if the user ID equals the creator column that we have created in table, to-do table. Okay, cool. Now let's call this method. Let's make a request to this delete root with this button. We can go to our to-do item component, and in this component we can create our try catch block, and we can simply const response await fetch like this. And as you can see, we need to pass our to-do ID like this. What you pass into this string is what you get from this params, this ID, right? Okay, cool. Now we can set our method as delete like that, and if response is okay, actually we can get our const data like this. Okay, cool. Now let's try to delete this to-do. Click and refresh. As you can see, we deleted our to-do from our database. There is no to-do like this. Okay, cool. Now we can create our patch method to update to-do's data. In our to-do component, I created this select to update the status of to-do. But to update the status, we need to first create our patch method in the root handler, right? Okay, cool. Now we can go to our dynamic root handler, and in this file, we can create another method for patch and export async function patch, and we will get our request. Request like this, and also we need to get our params again. Params ID will be string like this, right? Now we can get our ID from params and create our Supabase client. But first we need to get our new status, right? And const status equals await.rec.json like this. And if there is no status or status is type of status not equals string, we can send our error message like that. And now we can create our Supabase client, and also we can check if user is logged in. Okay, cool. Now we can update our to-do. Like this. And with the select method, we can get the updated to-do, and if there's error, we can return our error message. If there is no error, we can simply return this data, new updated to-do. Okay, cool. Now we need to set our row level security policy again. Policies and new policy for update. Use this template for authenticated users, and auth.uid equals creator. We can copy and paste into this section as well. Okay, cool. Now we can save this policy and create our update handler in this select, right? We can go to our to-do status component, and in this change handler, we can set this to the async function, and we can try and catch const rest await fetch our API to-do and our to-do ID, and we can set our method to patch. And also we need to send our headers, and also we need to send our status value like this. Const data console.log data, and we can console.log if there is an error. Okay, cool. Now we can try to change our to-do like this, and if we refresh the page, as you can see, our to-do is now done, and we can make this in progress like this, and we can go to our table and to-dos, check if it's in progress. Yeah, it's in progress. Okay, cool. Now I will show you a cool trick how we can refactor our code to prevent the repetition of some kind of logics. As you can see, we have repeated ourselves by checking this session in every method, right? But if we are gonna protect our old roots, we can check this session in our middleware, since it will be run in actually before every API route, right? In here, we already get our session, right? We can get our session like this, session away. And also we can get our path name like this. And we can write a logic here. If it's an API run and user is not logged in, return 401 like this. If path name starts with API and there is no session, we can simply return this. JSON and message, you are not authorized to make this request, right? Okay, cool. Now we can delete all logics that we have created before. In our patch, we don't need to check if user is logged in anymore. And also in this delete method, cool. And also we can go to our post and get root. But in this post method, we need to get our session because we will set our user ID. But we can get rid of this logic, right? Okay, cool. Now let's try to make a request from Thunder client. As you can see, you are not authorized to make this request. So we don't have to repeat ourselves by creating this check logic in every run. Okay, I think now we are done with the REST API part, but I'm going to show you how we can create a rate limiter, and also we will dive into course headers to make these routes more secure. We are going to be using Upstash for serverless rate limiter. To create our rate limiter, first we need to create an account in Upstash. You can sign in with GitHub and you can create a new database with your free tier, but I already created this rate limiter. And in this rate limiter database, we can create our rate limiting logic with Next.js and Upstash. But to create this logic, first we need to add some package. Yarn add Upstash Redis and also Upstash rate, need to check the name, rate limit, like this. And we can go to our post route. And also you need to set your environment variables, this one and this one. We can copy and paste into our .env.local file, upstash redis rest URL equals this, and upstash redis rest token. Okay, cool. Now we can create our rate limiter in here. rate limiter like this. And to create our rate limiter, we can use const rate limit equals new rate limit, and we need to import this from Upstash. And we need to configure this. First, we need to set our Redis with Redis, and we need to import this from Redis, and from .env. It will create our Redis instance with environment variables that we set before into our .env local file. And also, we need to set our limiter like this. This is the part that you want to define your rate limiting logic. For example, we can create this kind of logic. Rate limit dot sliding window 3 and 60 seconds, which means that 3 requests per 60 seconds per minute, right? You can change this limit based on your requirement. Okay, cool. Now we need to set our identifier like this. And this is gonna be our session.user.id. But we need to set this after this, right? Because we need to get our session. Okay, cool. Now we can copy this one into here as well. Okay. Now it will return a success object if but this is gonna be string. Okay, cool. If the request is not more than 3 requests per minute, it will return this success object. If no success, we can say that you are sending too many requests. Else we will continue to insert a new to-do, right? Okay, cool. Now we can go to our add new to-do handler. And we can try to add new to do like this. And let's check in our for request if we can create another to do. As you can see, there's an error, right? In error, because we need to get this data, and console log data.message like this. Okay, let's try again. Okay, we need to log in. Okay, cool. Now we can try to create a new to-do. Upstash Redis REST token. Oh, sorry. We have a problem here. Okay, cool. Now we can try again. Add to do. We have added. Now it will throw error. As you can see, you are sending too many requests. And in our rate limiter, we set our identifier as user ID. This means that if another user try to fetch or make another request, they will be able to make these requests. This rate limiting is based on user ID with this identifier. Also, maybe you can get the rate limiting numbers from the user database. For example, you can set different limits based on user account, right? Yeah, this is so cool. Actually, you don't need to create some kind of complicated logics. You can just use this helper function and create your rate limiter with Upstash. Okay, the last thing that we will focus on is course. For those who are not familiar with course is a method, actually a mechanism that you can check the origin of request. And if it's not in your allowed list, you can simply reject this request. For example, you have your website, your API, and your mobile application. You can put these origins in a list, and if the request is not coming from the origin that listed, you can reject this request, which means that you can make your API much more secure with this method. Okay, cool. Now let's create this course logic in our middleware function, because we don't want to check this in every room. We don't want to repeat ourselves, right? Okay, first we need to get our origin from our request headers like this. rec.headers.get origin. And if it's an API route, check the course origin like this. If there is an origin and the path name starts with API, we can run this logic. But first we need to create our allowed origins list like that. And to create this list, first we need to check our environment like this, because if we are in production environment, we will have a different origin. If we are in the development environment, we will have our local host, right? That's why we need to set different origins based on our environment. If it's production, it will be like https your url.com, or the environment is preview. You can set your preview.yoururl.com like this, or which means that it's in development environment, you can set your http not stp local host 3000, like this. Okay, cool. Now we can create our const is allow. We can create our helper function to check if the origin is listed in this allowed origins. And also in this if statement, we need to check if is allowed or not. Okay? If it's not allowed, we will return a new next response, and this is gonna be null because we don't want to set anybody. And also we can send our status text like this. Okay, cool. Now to try this, I will put another origin into our list, https www.google.com, like this. Okay, and let's go to Google and try if it works. We can simply write our fetch call in the console like this, http localhost 3000/API/todo. And as you can see, we still get this course error, and the promise is not fulfilled, it's rejected, because we need to send our origin with our response to. To create this logic, we can go to our get method in the to-do root, and instead of this return statement, we can delete this and new, and also we need to wrap this into JSON stringify like this, because this is not JSON anymore, but we need to send as JSON this, right? And also we need to send our headers. Our content type will be application and JSON, and our access control headers, I will copy this from here. Access control allow origin header will be origin or star. If there is no origin, it will be star, because if there is no origin, which means that we are making request from Thunder client or Postman, because they don't have any origin. But we need to be able to make requests from those kind of clients to try our API route, right? That's why I put this. And also we need to get our origin in here, right? Like this. Okay, cool. Now we can go to our middleware and comment out this section for a moment, because we don't want to check if there is a user, since we cannot provide session from Google, right? Okay, let's refresh the page and run this again. And as you can see, it's now fulfilled and there is no course error. If we remove this origin from our allowed list and try to fetch again, as you can see, we are getting course errors. Thank you for watching this video, guys. I know that it's a long one, but if you have come this far, please don't forget to subscribe my channel. And if you like the video, please hit the like button.